Hi, I am Vivi. In this video for our decision support class, I will teach you how to determine what is the approach depending on the question. Let's begin. Descriptive statistics. It gives you the basic, general idea of the data. We have the mean, the median, and the mode. Measures of central tendency describe the center of the dataset. We have the variance and standard deviation. Measures of variability describe the dispersion of the dataset. And we have count. Measures of frequency distribution describe the occurrence of data within the dataset. Now let's see correlation. Correlation tries to measure any statistical relationship between two variables. And these variables have to be continuous. For example, what is the correlation between the patient's blood pressure and the medication used? In this example, there are two variables, the patient's blood pressure and the medication used. One sample t-test. It tries to prove a claim in a population. It considers the analysis of one column or only one variable. It is recommended to be used with samples smaller than 30, and it could be continuous or categorical variables. One sample t-test for mean is the numerical or continuous variable, and it tries to prove the claim about a population's mean. For example, is 30 the mean age of the students in our class? One sample t-test for proportion is the categorical variable. For example, are the male students in our class 60%? As you can see, the variable in the one sample t-test for mean is the age, a continuous variable, a number. The variable in the one sample t-test for proportion is if the student is a male or a female, a categorical variable. One is trying to measure mean and the other one proportion. Now, one sample z-test. So we also have the z-test for proportion and for mean. How to know when to use z-test or t-test? Basically, for larger samples, more than 30, we use the z-test. For smaller samples, less than 30, we use the t-test, and both can be used for means and for proportions. For example, one sample z-test for mean. Is 30 the mean age of the students at the university? We are trying to prove a claim about a mean in a sample bigger than 30. This is not our classroom anymore. This is the entire university. Now an example for one sample z-test for proportion. Are the male students 60% from the total students at the university? Here we are trying to prove a claim about a proportion in a sample bigger than 30 again, the university. Now, two sample t-test. In this case, instead of one variable, like in the one sample t or z test, in the two sample, we have two variables. Since it's a t-test, again, it is recommended to be used in a sample smaller than 30. Let's see an example from a two sample t-test for means, where the unknown population mean of two groups are equal or not. For example, native English speakers in our class took a written English test with the non-native English speakers in our class. Is the mean score from the native English speakers different from the non-native English speakers? As you can see, one of the two variables from this example is the type of student, native English speaker or non-native English speaker. And the score, which is a number, a continuous variable. We have two variables. Now let's see an example for the two sample t-test for proportions. Native English speakers in our class took a written test with the non-native English speakers in our class. Is the proportion of the native English speakers who got an A different from the proportion of the non-native English speakers who got an A? And here, as you can see, one of the two variables from this example is the type of student, native English speaker or non-native English speaker, and the grade, A, B, C, D. In this case, our both variables are categorical. Now, two sample z-test. In the two sample z-test, we are talking about a larger population, but it's the same thing as the two sample t-test. For example, native English speaker in our university, not in our class, in our university, took a written English test. Is the mean score from the native English speakers different from the non-native English speakers? We have our two variables, the score, which is a continuous variable, and our categorical variable if the student is English speaker or non-native English speaker. And the two samples Z test for proportion. We have the same example, but in this case, it's asking for proportion, and our sample is at the university level, not at our class level. And our two variables, both of them are categorical. Now, one way ANOVA. ANOVA also tries to prove a claim about groups within a population. To understand it better, ANOVA could be a 3-sample test, since it can be conducted with 3 or more groups. There is not a limit in the sample size. It could be as large or as small as needed. The dependent variable must be continuous. The independent variable, when categorical, must include at least 3 groups. Otherwise, just use a t-test or a z-test depending on the size of the sample. Let's see some examples. Native English speakers whose English is their only language. Students who spoke 2 languages at home, including English and a second language, and non-native English speakers in our university took a written English test. In our data, we have their overall score. The question is there a difference between their score? What group of students got a higher score? Here, the first variable, the type of student, a categorical variable, has more than 2 groups. It has 3. Now we are classifying between the students whose first language is only English, whose first language is only English and another language, and whose first language is not English. 3 groups. And our second variable is a continuous variable, is the score. What score they got in the test. That's one way ANOVA. Now let's see two-way ANOVA or factorial ANOVA. The same thing as the one ANOVA, but instead of one, we have 2 independent variables. For example, we have the same example, native English speakers whose English is their only language, students who speak 2 languages, and non-native English speakers in our university took a written test. In our data, we have their overall score, but we also have their level of education, if they are undergrad, master, or PhD. The question is there a significant difference in the score between the type of English speaker and their level of education? We are including another variable here. We have 3 variables, the score, the level of education, the score which is our dependent variable, the level of education, a categorical variable, and the type of a student, another categorical variable. Regression. The main difference between regression and the other test is that here we're trying to predict a value or test if the value can be predicted. We are not comparing data that is already given. Here in regression, we are trying to make new data. This is our example. Native English speakers whose English is their only language, students who spoke 2 languages at home, including English and a second one, and non-native English speakers in our university took a written test. In our data, we have their overall score, level of education if they're undergrad, master, PhD, and hours of study before the test. In simple linear regression, one dependent variable and one independent variable are used, and the outcome or the dependent variable that we are trying to predict is continuous, is a number. For example, can the hours of study predict the score? Hours of study is one of the variables, is a continuous variable, and the variable that we want to predict is also a continuous variable, the score, a number. Multilinear regression. We have one dependent variable and more than 2 independent variables. And again, the outcome or the dependent variable that we are trying to predict is continuous, a number. Can the hours of study, the type of a student, and the level of education predict the overall score? The dependent variable that we are trying to predict is the overall score, a continuous variable, a number, and we are using 3 variables, the hours of study, a continuous variable, the type of a student, a categorical variable, and the level of education, a categorical variable as well. And finally, logistic regression, where we have one dependent variable and multiple independent variables, but in this case, the outcome or the dependent variable that we are trying to predict, it has to be categorical or discrete. In other words, the answer should be a yes or a no. This is what we have to add to our example to make this logistic regression example. Using the results, using this data, the university awarded some of the students with a prize according to their performance in the test, an effort considering that not all of them have the same background. Our data also has a column telling us if that particular student was awarded or not. How does all the data, including type of student, hours of study, and level of education, affected if the student was awarded or no? The answer for this question is not continuous. It's not a number. It is asking, can we predict if the student was awarded or no? If the answer is yes or no, it's logistic regression. So far, we have studied descriptive statistics, correlation, one sample t-test, one sample z-test, two sample t-test, two sample z-test, one-way ANOVA, two-way ANOVA or factorial ANOVA, simple linear regression, multilinear regression, and logistic regression. In the second part of this video, you can test what you have learned by guessing the right approach according to the question given. Thank you so much.